Black holes are some of the most mysterious things in the universe. They seem completely baffling. Where do they come from? And what happens if you fall into one? You're watching video from ThinkNova. Stars are massive collections of mostly hydrogen atoms, formed when enormous gas clouds collapse under their own gravity. At their cores, nuclear fusion smashes hydrogen atoms together to create helium, releasing a staggering amount of energy. This energy, in the form of radiation, pushes outward against gravity, keeping the star in a delicate balance. As long as fusion continues, a star stays stable. But for stars much larger than our Sun, the core's extreme heat and pressure allow heavier elements to form. This process continues until the star produces iron. But unlike the previous elements, fusing iron doesn't generate energy. Instead, iron accumulates in the core until it reaches a breaking point. At this critical moment, the balance between radiation and gravity fails, and the core collapses in on itself. In less than a second, the star implodes, collapsing at a quarter of the speed of light and adding even more mass to the core. It's during this dramatic collapse that the universe's heavier elements are forged, all in the fiery death of a supernova explosion. What remains is either a neutron star or, if the original star was massive enough, a black hole. When you look at a black hole, what you're really seeing is the event horizon, the boundary beyond which nothing, not even light, can escape. Anything crossing this line would need to travel faster than light to get out, which is impossible. So we see a dark sphere reflecting nothing at all. But if the event horizon is the black part, what's the hole? That would be the singularity, a point where all the black hole's mass is concentrated. We don't fully understand it yet. The singularity might be infinitely dense, with no surface or volume, or it could be something entirely different. For now, it's like dividing by zero, an error in our understanding of physics. By the way, black holes don't suck things in like giant cosmic vacuum cleaners. If our sun were swapped with an equally massive black hole, Earth's orbit wouldn't change. Sure, we'd freeze to death without sunlight, but we wouldn't get pulled in. So, what happens if you fall into a black hole? Time behaves strangely near black holes. From the outside, you'd seem to slow down as you approach the event horizon, eventually appearing frozen in time and turning red before disappearing. From your perspective, though, you'd see the universe speed up, almost like fast-forwarding into the future. Once you cross the event horizon, two possible fates await. The first is spaghettification, gravity stretching you so intensely that your body is torn into a thin stream of atoms. The second is an instant death from hitting a firewall of high-energy particles. Neither is ideal. How soon you die depends on the black hole's size. Smaller black holes kill you before you even reach the event horizon, while larger ones might let you survive a bit longer. The further you are from the singularity, the longer you might last. Black holes also vary in size. There are stellar black holes, just a few times the sun's mass, and supermassive black holes, which sit at the centers of galaxies. The largest known supermassive black hole, S5 14+81, is 40 billion times the mass of the Sun and spans 236.7 billion kilometers, 47 times the distance from the Sun to Pluto. Despite their power, black holes don't last forever. They slowly evaporate through Hawking radiation, a process involving virtual particles popping into existence near the event horizon. One particle falls into the black hole while the other escapes, making the black hole lose energy. This happens incredibly slowly at first, but as the black hole shrinks, the process speeds up. When a black hole is the size of an asteroid, it radiates at room temperature. When it's as small as a mountain, it shines as brightly as the sun. In its final moments, the black hole releases an explosion equivalent to billions of nuclear bombs. But for the largest black holes, this process will take a Google years, so long that the universe will have become uninhabitable long before the last black hole evaporates. But the story of black holes doesn't stop there. In fact, black holes are not just destroyers, they can also be creators. These cosmic giants play a crucial role in shaping galaxies, influencing the formation of stars, and even determining the large-scale structure of the universe. It might sound ironic, but without black holes, the universe as we know it might look very different. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. These enormous black holes are millions or even billions of times the mass of the Sun, and they've been quietly influencing their surroundings for billions of years. How did they get so massive? Scientists are still trying to figure that out. It's possible they grew by swallowing gas, dust, and stars over time. Or maybe they started off big, forming directly from gigantic clouds of gas in the early universe. One fascinating thing about supermassive black holes is their ability to feed on surrounding material. When a black hole is actively consuming matter, it creates a glowing disk of gas and dust called an accretion disk. This disk can shine so brightly that it outshines the entire galaxy, creating what we call a quasar. Quasars are some of the brightest objects in the universe, visible from billions of light years away. They act like cosmic lighthouses, helping astronomers study the distant early universe. But black holes don't just influence their surroundings by feeding. They also unleash immense energy through powerful jets of particles that shoot out from their poles at nearly the speed of light. These jets can extend for thousands of light years, affecting nearby galaxies and even the intergalactic medium. Scientists believe these jets play a key role in regulating star formation, either by compressing gas to form new stars or by blowing gas away, preventing new stars from forming. It's a delicate cosmic balancing act. And while black holes seem eternal, they have a mysterious beginning and a definitive end. In their final stages, as they shrink due to Hawking radiation, black holes might hold the key to some of the universe's greatest mysteries. For example, what happens to the information about the matter that fell into a black hole? This question, known as the information paradox, has puzzled physicists for decades. Some theories suggest the information is lost forever, while others propose that it might be encoded in the radiation emitted by the black hole as it evaporates. There's also the tantalizing idea of wormholes, hypothetical tunnels through space-time that might connect distant parts of the universe. Could black holes be gateways to these wormholes? While it's purely theoretical at this point, the idea has inspired both scientific research and countless science fiction stories. If wormholes do exist, they could offer a way to travel vast distances across the universe in a fraction of the time it would normally take. But for now, they remain a fascinating what if. As we continue to study black holes, our understanding of them keeps evolving. With powerful new telescopes like the James Webb Space Telescope and advancements in computational simulations, we're peering deeper into the universe and uncovering new insights about these enigmatic objects. For instance, scientists recently captured the first-ever image of a black hole's shadow, a groundbreaking achievement that brought us closer to understanding these cosmic mysteries. The more we learn, the more questions arise. Could black holes be the seeds of new universes? Do they hold the answers to the nature of space-time itself? And what role will they play in the distant future of our cosmos? These are the kinds of questions that keep scientists, and all of us, wondering. For now, black holes remain one of the greatest wonders of the universe. They are both terrifying and beautiful, a testament to the incredible power and complexity of the cosmos. As we unravel their mysteries, one thing is certain: the story of black holes is far from over. It's a tale that will continue to inspire curiosity, spark imagination, and deepen our understanding of the universe for generations to come. So, the next time you gaze up at the night sky, Remember, somewhere out there, hidden among the stars, are these silent giants, shaping the universe in ways we're only beginning to understand. And as we learn more about them, who knows what other cosmic secrets we'll uncover? Stay tuned. This journey through space and time is just getting started.